Let's try to understand how to write equation of the lines, and that will prepare you for your test. The question here is, determine vector equation of each line. I've asked for vector equation in this case because we do have questions relating vector equation with other forms of equation. So you can always convert one form of equation to another. So let's try to understand that in different scenarios, how do we write a vector equation of the given line? A. Parallel to x-axis and through the point 1, 2, 3. Second, perpendicular to 3x minus 2y equals to 3 and through P a point which is 3, 4. C is the x-intercept of the line is 4 and the y-intercept is 6. And vector equation of your line which is y-axis. So you can pause the video, answer the questions, and then look for my suggestions for this test problem. Now here are my suggestions. Now when we say vector equation, then basically we're trying to write equation in this form that will give you a point here, maybe x, y, z in general. Now in case it is R2, then we'll use xy of course, plus t times direction vector, and let's say this is ABC. So that in general will give us the vector equation of our line. So we are interested in the point and the direction. So first one is parallel to x-axis and through this point. So we have the point, so we just can write 1, 2, 3, and parallel to x-axis means we have a direction also. What is the direction in this case? X-axis. So we can write this equation as, so for A, we can write this as the point is 1, 2, 3 plus t times x-axis is 1 and others are 0, right? So that gives you parallel to x-axis. So from origin, you just move in x-axis direction. Okay, now part B is perpendicular to 3x minus 2y equals to 3 and through the point. Now if I have an equation perpendicular to this line, well this is Cartesian or scalar format in which normal is given to us and the normal is 3, given normal is 3 minus 2. Now the line which is going to be perpendicular, its normal will be what? So normal of a perpendicular line should be, we'll just flip it and we get 2, 3 and change one of the signs. So preferred sign to be changed to this one. Now we know the normal. Once you know the normal and the point which is 3, 4, you can write down the equation. So equation will be, let me write it like this. 2, that is x coefficient, plus 3y plus c equals to 0. Now we should find what c is for the point 3, 4 to be on this line, right? So 3 is for x and 4 is for y. So we get 2 times 3, which is 6, plus 3 times 4, which is 12, plus c equals to 0. And that gives us a value of c, which is minus 18. So it gives us c equals to minus 18. And if I plug in minus 18 here, I get my answer, right? And therefore, my equation for part B is 2x plus 3y, let me write here, 2x plus 3y plus c, which is minus 18. Minus 18 equals to 0. So that becomes a line which is perpendicular. You can always test it. If you do dot product of these, you'll get 0. And if you plug in 3 here and 4 there, you will get 0. So it will satisfy the line. Part C is the x-intercept of the line is 4 and the y-intercept is 6. Now we can use a line in Cartesian plane to get this equation very easily. But we need to find an equation. Well, for this also we wanted to find equation in vector equation of a line. I forgot that part. So what you do now is that you can change that to vector equation of a line. Now let me get back to question number B, part B, which is kind of simpler. let's give vector equation of this line. So vector equation of part B will be, so we'll redo part B, right? I kind of forgot that we are interested only in writing vector equation of a line. Now since this is the normal given to us and we want perpendicular to this line, so the normal becomes our direction, correct? And point is given to us. And therefore the vector equation of this line, let me call this line as L2. Line L2 is equal to the point 3, 4 plus t times 3 minus 2. So that will be our vector equation of the line. Now as an added exercise, I would like you to transform this equation and get it in this form. That is indeed a good question to work on. Okay, thank you. In time, I just saw this. Okay. Part C is x-intercept of the line is given to us and y-intercept is given to us, and we need to find vector equation. Now x-intercept basically means what? The point is 4, 0, and y-intercept is a point which is 0, 6. Now you know 2 points, so you can always find the vector equation, and you can write this line L3 as equal to any one of these points, let's say 4, 0, plus t times direction. So direction will be 0 minus 4, which is minus 4, and 6 minus 0, which is 6. We can simplify this. We can factor out 2 from here and then write our equation as 4, 0 plus t minus 2, 3. So that is even better, right? So we'll write this equation kind of here. So let me just squeeze it in. So it will be 4, 0 plus t times minus 2, 3. Okay, that's how we'll write. Part D, y-axis. Now y-axis is what? If we are looking into R3, you have to move along the y-axis only. So in that case, we are not at all moving along these two lines. Any point on y-axis, we could actually take a point, let's say call it equation line 4, origin will be a point on y-axis. So think about 0, 0, 0, no need to write it now, and t times what? Y-axis is this direction where you're not moving along x and z, so it is 0, 1, 0. So that becomes the equation of the line which represents y-axis in R3, and if I write L4 as just 2 of them, t times 0, 1, then it becomes vector equation in R2, right? So that is how we can represent these lines. I hope you appreciate the variety which you have dealt with in these 4 questions and gone through real good examples to understand the concepts. Don't forget to link our equation number, let's say call it 1, with the answer here 2. Okay, this indeed is another good question to work on. So I hope with this you get good preparation for your test. All the best. Thank you.